what we're doing with exponents. So my first question is just what are the first 10 powers of 2? And maybe you'll just practice that by counting on your fingers. But then the next 2 questions, I'd actually like you to write them down somewhere. And I'm just going to review with you real quick, just so we're all familiar. And maybe this is what, oh, I actually already have it up there. I wanted you to remember that when you look at function notation, that's just the F, function notation. That means F of input equals the output. So when you're doing function notation, you are literally looking at this function. And you're saying, well, if the function is f of x equals 2 to the x, then whatever I put in right here, that's what I'm going to put into the exponent. So when you see f of 5, f of -2, f of 0, f of 10, those are all going to be the exponent. Then you just substitute into the expression, and you calculate it. So function notation is forward. It's just normal plug and chug. It's when you do the inverse function. So again, I say the function is 2 to the x. What does f inverse of 128 mean? What does f inverse of 8 mean? What does f inverse of 2 and what does f inverse of 1? Now you're asking, what would the exponent of 2 have to be to equal 128? That's what you're saying. What would the exponent have to be for 2 to the something to equal 128? Likewise, f inverse of 8. What would the exponent have to be so that it would equal 8? And maybe that's a good question to ask. What would the exponent have to be? What would the input have to be? And that's what you're asking for down here. Okay? And that's why I wrote down this as a reminder. F inverse of the output equals whatever the input would have to be into that formula to actually equal that number. Okay, so there's some challenging ones in there. And then last, in order to solve 2 to the 4x minus 2 equals 64, describe in English the 2 steps you'd have to follow. So don't do this on your own. Go ahead and turn to your neighbor and have a conversation about what those things equal and why. So everybody go ahead. You have 3 minutes. There's one right here. Or there's a okay, there's one right there in practice. So I don't so basically what I would say is the bigger you get the number inside of parentheses. So, but now all right, folks. I sense the volume in the room getting lower, so I'm thinking that more of you are close to being done. So let's go ahead and try it out. I'm going to call on you for some answers. Although maybe the first one we can just all do together as a group. So let's try it. We're going to count multiplying by 2s out loud, and we'll do 10 of them. So we all know where it starts. It starts at 2. And then 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. This is where it gets tricky. 128 times 2? 256, and then times 2 again? 512. Is that it? Oh, one more? Okay, so after 512 times 2, 1,024. So the first 10 powers of 2 take you up to 1,000. Okay. Now, how about the second one? I'm just going to call around the room for the answers on these. So we're just talking about the function 2 to the x. What is f of 5? So Jesse, what is f of 5?
2 to the 5th power?
Yeah, 2 to the 5th power, which is? 32, yeah. 2, 4, 8, 16, 32. So yeah, f to the 5th literally means 2 to the 5th. So when you look at that function notation, you're really saying plug 5 into this function, which means 2 to the 5th, and so it's 32. Okay, what's f of negative 2? A little more of a challenge here. Deegan, you want to try it? So what's f of negative 2? Yeah, that would be 2 to the negative 2, and then the negative exponent means reciprocal, and 2 squared is 4, so it'd be 1 over 4, just like Deegan said. That'd be 1 over 4, so that's 1/4. I'll write that down. So that one is 32, and that one's 1/4. Okay, f of 0. F of 0, what's that one, Nick? Yeah, just 1, because that'll be 2 to the power of 0, which anything to the power of 0 is just 1. All right, and then finally f of 10. Well, we all just did that one. What's f of 10? 1,024. So here we go. So that's really 2 to the power of 10 equals 1,024. Now again, this number was the input, and this number was the output. So when we talk about an inverse function, we're about to do f inverse, we're looking at the answer. And we're trying to go backwards and figure out what the exponent would have had to have been. So f inverse of 128, Chris, what would the exponent have to be? 7. The answer is just 7. Right, just 7. You just say 7. It's as if somebody said, what would the input have to be, or what would the exponent on 2 have to be? The answer is just 7. You wouldn't say the answer is 2 to the 7th, because that's the question f of 7. You would just say 7. Okay, how about f inverse of 8, Crystal? What would the exponent have to be so that 2 to the something would equal 8? It'd be 2. More than 2. 2 squared is 4. 4 is too many. 2 times 2 is 4 times 2 is 8 times 2 is 16. So 2 to the what equals 8? 3, exactly right. 2 to the 3. So the answer is just 3. What would the exponent on 2 have to be so that it equaled 8? It would be 2 to the power of 3 equals 8. And so the input answer is 3. Yeah. Okay, great. How about f inverse of 2, Sydney? Now 1. What would the exponent have to be? It would have to be a 1, because 2 to the power of 1 equals 2. So the answer is 1. And then how about f inverse of 1? What would the exponent have to be? Eduardo? 0. Yeah, because 2 to the 0 equals 1, and so the answer is 0. Okay, so I hope that was a little bit of extra good practice on remembering the difference between function and inverse function. Okay, and then the last question, in order to solve 2 to the 4x minus 2 equals 64, describe in English the steps you'd have to take. What's the first thing you'd have to do, Emily? What's the first thing we want to do?
You want to change the 64 to 2.
Yeah, you want to change the 64 to a base of 2. Currently, what is the base right here? 64. Currently, the base is 64. It's 64 to the power of 1, but we don't want a base of 64, we want a base of 2. So Emily, 2 to the what equals 64? And notice, folks, I just asked an inverse question. I just asked the question, f inverse of 64 equals what? Meaning, what power of 2 would you need to equal 64? I think it is 6. 2, 4, 8, 16, 32, 64. So it's 2 to the 6. Okay, great. That was the first step. Thank you, Emily. Equate the bases. What's the second step, Jasmine? Exactly. Equate the exponents. And that step is a little easier. You just set the exponents equal to each other and solve with standard algebra. So now we would say 4x minus 2 equals 6. And away you go solving. You add the 2 over, and then you divide off the 4. And did everyone get 2? Okay, do we know that 2 is the right answer? How do we know? Yeah, we would just have to plug it in right there. So 4 times 2 is 8. 8 minus 2 is 6. And indeed, 2 to the 6 is equal to 64. And so we know we have the correct answer. The answer is 2. Right? Even though the exponent that it equals is actually 6, but x is equal to 2. Okay, well, very nice, folks. Let's take a look at our calendar. We're coming up on a test. Isn't that so exciting? We're almost done with chapter 5 and chapter 11. So let's just take a look here. So our calendar, today is January 29th, and I think we already started 11.2 and 11.3, and we're actually already on 11.7. So we're a little ahead of the game. And so what that means is that today we're going to finish chapter 11. And on January 31st, I won't typically be able to do this with you folks, but we'll do a review activity where we will review everything on your practice notes, your notes packets, and we'll review the entire practice test together. So the entire practice test that I just gave you, you would most benefit from Wednesday's class if you come to class already having attempted every problem. You know, just attempt every problem. Don't stress out if you got it right or wrong. Just attempt every problem off the top of your head. Go with your gut instinct. Try out every single problem. And come to class with the practice test complete. And then we'll spend that hour doing a review exercise. And you could even, we might even have some time that you could work on just finishing all of that. Because everything is due on the day of the test. Your notes packet and your practice test. Sarah.
Last week we already got a check.
You're kidding. So what, I just gave it to you. What's that?
It's different problems too.
Well, that's totally not necessary.
Well, the difference is the person has an answer.
Yeah.
Oh. Well, folks, you might as well just pass them all up. I didn't realize I had already printed them. Oh, but then again, if you want to keep it, that's extra practice. Right? So yeah. Yeah, exactly. Good point. You know, it seems to me like I just goofed, guys. I think I just goofed. So if you want to take that and recycle it, you can just recycle it. I would definitely keep that first practice test as your real practice test because it has an answer key, and the second one doesn't. I don't know what I was thinking. Yep. So you can recycle that one if you like. Yes, I do. You mean of the first one? Let me check. I don't think I have an extra one with me because I was just looking in here and I didn't see it. I think I'll have to get it for you from my office. Yeah, come up to me to see me in the office. All right, well, so in any case, the practice test you already have. That's the one that we're going to go over during next class. We'll go over the practice test. And then when you come in on February 5th, oh, you'll all be so ready and hyped up and ready to take your test, and I'll give you the full 2 hours to do it. All right, well, let's see here. Your quiz. I will give you back your quiz at the end of class, and at the end of class, I will post the answer key to the quiz. So what I have is the quiz that I did. I showed all my steps, and I'll give you back your quiz, and I'll post the answer key online. That way you can kind of look. If you missed any problems, you can go back and look at the full solution and kind of see why it is what it's supposed to be. Now, even though I'm posting the answer key online, I also wrote on all of your tests. Okay, so if you got the problem wrong, I didn't just mark it off. I showed you the correct solution. In every single one of your quizzes, I already wrote out a correct solution if you didn't provide it. But you can still, if you want, go online and look at the full answer key. Please review it no matter what. Your test is on Monday, and that's when everything is due. Your notes packet, your practice test, and your memo. Okie doke. Any questions about the calendar, what we're doing? Okay. So, oh, I didn't say this, but on this day, after we review the practice test, if we finish everything, I might give you a preview of the next chapter, which is chapter 6. Okay. So, my joke for you for today, to get us started, is a knock-knock joke, so I hope you all reply. Knock-knock. Interrupting. Has anyone heard that one before? Maybe you've already heard it, maybe not. Okay, well, anyway, I think it's a cute joke. So here we go. Oh, this is the key. I posted this online, so you can go onto Canvas and you can take a look at all the steps. All right? Yeah, if we have time, I'll go over more of that at the end of class. Let's continue. We already did all this, right? Actually, no, we did number 17. We did 6 to the power of x equals 8, and we played around on our calculators, and we finally got an answer around to the 100th. So did anyone already try 22 to the x equals 27? So you would sandwich the answer. So first of all, I don't know what 22 to the x equals 27. I don't know what that exponent is. But I can go ahead and sandwich the answer. I know that 22 to the first is 22. And that's too small. And I know that 22 squared is something gigantic in the 400s. And that's too big. I should actually multiply that. What's 22? That is 22. There, 484. So what do you folks think? As a first glance, we know the answer has to be between 1 and 2. What will it be closer to, 1 or 2? 1. Definitely closer to 1. So what do we think as a first glance? X equals 1.06. Whoa, you're getting really specific. Now, like 1.06 is already to 2 decimals. What about just 1 decimal? Would we say 1.1, 1.2, 1.3, 1.4? What do you think? Definitely not 1.5. 1.5 is right in the middle, and 27 is not in the middle of 22 and 44. 27 is really close to 22. So who votes for 1.1? Okay, a few of you. Who votes for 1.2? Okay, not as many of you. Okay, well, let's try 1.1. So at that point, you would just try it on your calculator and see how it goes. You will have one question like this on the test, where it's up to you to figure out what the power of x, what the exponent is to 2 decimals. So we tried 22 to the 1.1, and that's 29. Well, how many of you? 22 to the 1.1 is 29.96. Too big or too small? That's too big. So we need to once again sandwich between 1.0 and 1.1. So what's a number between 1.0 and 1.1? Who wants to?
1.04.
1.04? Are you telling us the answer, or is that just your guess?
No, that's just
Okay, great. So 1.04. So again, it's just a guess. You just try it. 22 to the power of 1.04. This is one reason why you need a calculator on the day of the test, right, to do these exponents. There's no way to do this in your head. All right, well, that turned out to be 24.895. Too big or too small? Too small. So we need something between 1.04 and 1.10. We're sandwiching it in between them. So what do we think? 1.07, Crystal says. So let's say 22 to the power of 1.07. We'll give that a shot. 22 to the power of 1.07. Ooh, very close. 27.31. Too big or too small? Just barely too big, right? So I wonder what 1.06 would be. That one's too small? Oh yeah, that is too small. So considering that we want to round our answer to the nearest hundredth, which one of those answers would you choose? 1.06 or 1.07? You're probably 1.07 because it's only 0.31 away, and this one is 0.52 away, so technically this one's closer. Or what we could do is, let's say we actually knew the actual answer, that we actually knew what the answer would be. Let's see real quick. The answer is 1.0662545157. So did we make a correct choice by choosing 1.07?
Yeah.
Yeah, because that would round to 1.07. So we didn't really need to know the exact answer because going off of our gut, the 1.07 provided a number closer to 27 than that one did, and that's definitely the answer. So notice the answer is 1.07. The answer is 1.07. So if you wanted to write down x equals 1.07, that's the answer. Now, how would you write those in function and inverse function notation? What would the function notation be? F of what equals what? The input would be 1.07. Oh, sorry, we should write down the formula too, or first. F of x is equal to what, 22 to the x? Right. So what's our input? The input is 1.07, so f of 1.07 is roughly 22, right? Maybe I should make that an approximation symbol. So this, we're saying the function, so that's the input, so that's the exponent, and so f of 1.07 is roughly 22. How would you write that as inverse notation? So what's the output that we're looking for? 27. Oh, sorry, not 22. I'm so sorry. That should have been 27. No wonder I saw confused looks. I'm so sorry, folks. That should have been f of 1.07 is 27, whereas f inverse of 27 is 1.07. Yeah, it's just reversing the order in which we're talking about the input and the output. All right, wonderful, folks. So, yes, we're going to do money problems today. We're talking about money, specifically investing your money for an interest rate. Does anyone have any money invested right now, even in a savings account for which you're getting any interest? Maybe some of you do. The interest rates these days are pretty low, aren't they? What are the interest rates, like maybe 1%? Maybe 2%? Back in my childhood, a long time ago, I remember when interest rates were just commonly like 5, 6, 7%. And that was on just savings accounts. It was crazy. Well, anyway, now it's not so much. So I'm going to give us what might seem to be an outlandish example. I'm suggesting that we're going to invest $1,000 for 12%. That probably doesn't sound very likely because there's nowhere you can go today to invest your money for 12%, at least not in a checking account or a savings account or a money market account. Where could you get 12% return these days? Maybe in the stock market. Maybe if you had your money invested in a mutual fund or a stock portfolio, maybe you could be reaping 12%. But right now in a checking or savings, not so much. So here's what I want to look at. What's the difference between simple interest and compound interest? Do you maybe know already off the top of your head? If somebody walked up to you off the street and they said, what's simple interest, what's compound interest? What's an answer that you could give them? Diggin', you want to try?
Compound basically means that time is compounding onto your base pay.
Oh, now that's true. Oh, now by the way, folks, this isn't in your notes packet anywhere. It's just a screen where I'm going to talk with you folks about interest. So if you wanted to just take out a sheet of lined paper, you could follow along and write down everything I write down. But this is not in your notes packet. This would just be a lined sheet of paper type thing. So yeah, very good. What Deegan just said was that compound interest, perhaps this is one thing you remember, is that you earn interest on interest. And that's very exciting. You see, with simple interest, you're really just earning interest on your principal. So in simple interest, I invest $1,000, and by the end of the year, they've given me interest on $1,000. Whereas with compound interest, you put the $1,000 in, but as the year goes by, they start putting interest into your account. And so now you don't just have $1,000 in the account, you have $1,002. And now you're earning interest on $1,002 instead of just $1,000. And then a little later in the year, they give you a little more interest. And now you have $1,004 in your bank account. And you're earning interest on the $1,004. And so as time goes by, they actually are giving you interest throughout the year. And then you're earning interest on the interest in addition to the principal. So that's the other thing that you could say about the difference. In simple interest, you get interest once at the end of the year. That's it. It's just one lump sum. You had $1,000 in there. You earn interest on it. At the end of the year, they give you the interest, and then you're done. Whereas with compound interest, you get interest multiple times per year. Now, that's important. The fact that you're getting it multiple times per year, we use a specific variable for that, and that's called n. The number of times your interest is compounded per year. So for instance, if n equals 2, how many times a year are you getting interest? Twice a year. And they call that semi-annual. Semi-annual. What about n equals 4? If you get interest 4 times a year, what do they call that? Quarterly. Now you notice I skipped right over 1. N equals 1. Do we have a word for compounding interest once a year? Simple interest. Now you'll also notice I skipped over 3. Do we have a word for something that happens 3 times a year? I don't think we do. I'd be really interested if you could get on the interweb and find out what do you call it when something happens 3 times a year. I don't think we have a word for it in the English language. We just talk about quarters. Now, do we have n equals 5? Something that happens 5 times a year? No. What about n equals 6? What if it happens 6 times a year? If it happens 6 times a year, how often is it happening?
Every 2 months.
Every 2 months. And we do have a word for that. It's called bi-monthly. Wait, is it bi-monthly? Wait, bi-monthly is twice a month. So what would it be? I think it's, wait, no. Uh-oh, what is it? Bi-monthly is twice a month. So what is it every 2 months? Is it semi-monthly? Well, I don't want to say the wrong thing. Does anybody know? Are we all convinced that bi-monthly means twice a week? I mean, twice a month? We all get paychecks bi-monthly, essentially? Yeah. Okay, so I don't think it's bi-monthly. I think it's semi. I'm going to put semi-monthly, and I'll just put a little question mark there that I could be wrong. That doesn't make any sense, because semi-annually is twice a, this should be bi-annually. Oh my gosh, the English language is confusing. Semi-annually definitely means twice a year. Okay, what about 7? Do we have a word for 7 times a year, 8 times a year, 9, 10, 11, 12? What's n equals 12? Yeah, monthly. That's just monthly. Are there any other numbers that we might have with words, English words? That might be it. There's one other n value you might see and that's n equals 365, which of course is daily. So those are the common time periods where a bank might offer you compound interest, and they'll give you the interest that many times. Now, usually a bank is going to do like quarterly interest. So like every quarter, they'll put a little interest in your account, and then your account is now larger, and you're earning interest on the larger amount, and you're like, wow, this is fun. I'm now earning interest on the interest I already earned. The only time you really ever see 365 compoundings per year is not if you invest your money. That's how credit cards charge you interest. Did you know that? Credit cards, so if you use a credit card, not just if you use the credit card. You know, you can use a credit card as much as you like, but you're supposed to do what? Pay it off every month, right? If you don't pay it off at the end of the month, guess how often they charge you interest? Daily. They charge you interest compounded daily. So that's what they do. Every single day, they charge a little interest on the money that you borrowed, and they add it onto it, and then tomorrow when they charge you interest, they're adding you interest on the money you spent on your credit card plus the interest they already charged you. Brutal, right? Credit card interest is brutal. That's why you want to pay it off at the end of every month. Okay, yes, Jasmine.
Isn't that what you're saying?
You know, I don't know how cars do interest. Like, for instance, mortgages, car loans. I don't know off the top of my head if those are daily or monthly. I don't know. That's a great question, Jasmine. Yeah, does anyone know?
They're usually monthly.
Car loans are monthly compoundings?
Yeah.
I don't know. Good question, though, because this is how you borrow money from people. They're going to charge you interest, and they normally do it more frequently than not, right? Okay, so folks, that's simple interest. You just get interest once at the end of the year, whereas compound interest, you're getting interest multiple times per year, depending on the end value they give you, and then you're earning interest on top of interest. Okay, so that's the general idea. Now I want to give you a really concrete understanding of the formula behind this. Because maybe, folks, do you already know the formula for simple interest? I equals PRT. Did you already do a problem like that? Well, simple interest is just PRT. You just multiply the principal times the rate times the time. And that'll tell you how much interest you just earned. So let's just go ahead and do that problem. The interest that you'd earn in this scenario, what's our principal? $1,000. And then our rate, 12%, which is really 0.12. And then let's just do it for 1 year. Okay, we're gonna do both of these scenarios for 1 year. Okay, so in effect, our formula is 1,000 times 0.12. And that's very important because we're going to contrast that with what happens over there. Okay, so what's the answer? How much interest did you get? 120? Yeah, that's correct. You get 120 bucks. That's not bad at all. Right? So by investing that $1,000, by the end of the year, you just made 120 bucks. So that's some, well, of course, that's a really good interest rate. But that's motivation to save your money because you earn interest over time. Okay, so what's the compound interest formula? Now, actually, let me add one more formula here, okay? That's just how you calculate interest. That's just interest itself. The actual formula is A equals P times 1 plus R to the T. And let's see why that makes sense. That's the actual formula. So everybody write that down. That's still simple interest. And this is not just telling you the amount of interest, because the amount of interest was just the 120. This is giving you the full amount. This is the full amount in your bank account at the end of the year. So that's A. A stands for amount. That's the amount at the end. Why do you write that down? Amount at end. Okay, so what do we plug in? Our principal was still 1,000. And what was the interest rate? 12%. Yeah, 0.12 or 12% or 0.12. And then we're just doing it for 1 year. So it's to the exponent of 1. And so, if I'm just going to rewrite it. It's 1,000 times 1.12. Now, what's the difference when you multiply 1,000 times 1.12 instead of 1,000 times just 0.12?
Principal is included.
Yeah, it adds the principal in automatically for you. So it's not just the 120, it's a 1,120. It gives you the full ending balance. You can always do that in 2 steps, though, right? You could just calculate the principal and then add it. I'm sorry, you could just calculate the interest and then add it to the principal. But this formula adds it together for you automatically. So you don't have to do 2 steps. What was that, Kazini? Oh, okay. All right, so that's simple interest. Now, looking very closely at this formula, principal times 1 plus the rate, interest rate to the value of t, of how many years you left it in there, Now let's all write down the formula for compounded interest. A equals P 1 plus R over N to the exponent of NT. What does N stand for again?
For a time it's compound.
Yeah, the number of compoundings, which means the number of times they give you interest. That's what that means. The number of times they actually go into your bank account and whoop, drop a little money in there. How is that formula similar to this formula? How is it the same and how is it different? They both start with a P, right? What else? How else? They both have the 1 plus, and then what? Yeah, this one is just rate, that one's R divided by N, and then this one's just time, but that one's T times N. Now, let's just look and confirm that this formula makes sense. What if the number of compoundings is 1? What do we call that again? Simple interest. Everybody let N equal 1. What does the formula become? R over 1 is just R, and 1 times T is just T. So is the compound interest the same as the simple interest formula? If you let N equal 1. Yeah, if you let N equal 1, the compound interest formula is the simple interest formula. So really there's just one formula that you really have to memorize, folks, and that's this one. You might as well go ahead and memorize it today. There's just one formula you need to memorize, and that's the compound interest formula. Because if you just let N equal 1, it tells you the simple interest formula. So conceptually, I want to tell you now what this formula does. What this formula does. It's kind of funny. So I'm just going to show you conceptually, and then we'll actually do the formula. So take a look again at simple interest. Simple interest was 1,000 times 1.12. So everyone, what we're going to do right here underneath the compound interest, we're going to go and make a list. We're going to call it N equals 1, N equals 2, N equals 4, N equals 6, and N equals 12. Before we actually do the formula, I want to show you how they do it. When N equals 1, you take your principal and you just multiply it times the 12%, and that's it. You're done for the year. And again, it's 1.12. Why is the 1 in front of the decimal?
The principal is included.
Yeah, that adds the principal onto the interest. So you're getting the interest plus the principal together. If it was just 0.12 without a 1, you would just be calculating the interest. But since it's 1.12 with the 1, you're adding the interest plus the principal. Okay, so here's what happens. We're all agreeing that we're doing 12% interest. We're getting 12% interest, but we're going to vary how many times it gets compounded. And it's very simple the way they do this. You might even laugh when you see it. If you do N equals 2, you're going to get interest twice a year. Probably, let's say you invest your money in January. When would you get your first thing of interest? January, February, March, April, May, June, July? The 7th month, July? So you'd get interest in July and then again at the end of December. Or maybe better yet, you get January, February, March, April, May, June. You get it at the end of June and then the end of December. Does that make sense? That's when you get the interest. So watch what they do. You invest $1,000, and then at the end of June, they give you 6%, and then at the end of December, they give you another 6%. That's how they actually split it up. So in June, they're going to give you 6% interest on the $1,000. And then now you have that much money in your bank. And then at the end of December, they're going to give you 6% again on that balance. Now you might be saying to yourself, if you get 6% twice, does that really amount to 12%? I mean, on the one hand, you might think, yeah, that makes sense. Let's go ahead and total these up real quick. On your calculator, just multiply it, just straight up multiplication. The first one, 1,000 times 1.12, that's 1,120. Well, what happens if you take 1,000 and do it one piece at a time, times 1.06? How much money do you have at the end of June? Yeah, if you just multiply it times once, that just got you your June, your interest through June, and that's 1,060. But then multiply it times 1.06 again, which is what happens at the end of December, and then what do you have? Yeah. So what would you rather? Would you rather have simple interest of 12%, or would you rather 12% compounded twice a year? I mean, you'd rather have simple interest, compounded interest twice a year. because it actually ends up being a little more than 12%, which is kind of nice. Okay, so what would it look like if we did it 4 times? What if it was compounded 4 times? How would I, right here you can see what I did. I took the 12% and I divided it by 2, and I got 6% twice. So how would I compound it 4 times? Interest in the first quarter, 3% interest in the second quarter, 3% interest in the third quarter, and then 3% interest again in the fourth quarter. And what are all those quarters anyway? So that's January, February, March. At the end of March, you get 3%. And then they put that interest in your account. And then March, April, May, June. At the end of June, they give you a little more interest and put it in your account. And then July, August, September, they give you another 3%, put that interest in your account. And then October, November, December, they give you another 3%, and they put that in your account. So on your calculator, folks, all of you, I hope you all have your calculator out. This is such important for you to be seeing it on your own calculator. Do it one step at a time. Type in 1,000 times 1.03, and then just look at it and say, oh, okay. At the end of March, I'd have $1,030, and then multiply again, 1.03. March, April, May, June. At the end of June, I'd have $1,060.90. And then June, July, August, September. At the end of September, I'd have $1,092. And then at the end of December, I'd have $1,125. First of all, is this weird to know that this is how they do it? Did you expect this? Or maybe you already knew it. You're like, yeah, Mr. G, I already knew this. This is what compounded interest means. That they take that basic interest rate and they divide it into how many compoundings you want, and that's how much interest you get for each of them. And what are we noticing about compounded interest compared to simple interest? It's a little more, right? You actually end up getting a little more money. So compounded interest is better. Okay, so what about 6? What if you're compounding every 2 months? How much interest are you actually getting every 2 months? 2%. You take the 12% divided by 6, that's only 2%. So you're going to have your $1,000, and then every 2 months, bam, you get 2% interest. 2 more months, another 2%. 2 more months, another 2%. And how many total 1.02s do we have? 6. Did I get them all? 1, 2, 3, 4, 5, 6. And so you want to imagine that's what's actually happening to your bank account. That every 2 months, they're going to put a little bit of interest. How much? 2%. See, that's what makes this a little confusing. You're getting 12% for the year, but they're giving you 2% interest every 2 months. So go ahead and try it out on your calculator again. I really recommend that you type it and look at each button press. So that's the first 2 months, and then the second 2 months, and then the third 2 months, and then the fourth 2 months, and then the fifth 2 months, and then the sixth 2 months. What do you end up with? Did everyone get 1,126? Is that what you got? Yeah. Okay. So what are we noticing? What are we noticing with compound interest? If you're compounding your interest multiple times per year, what happens to the actual interest rate of what you're getting every compounding? The actual interest rate is much smaller than the original 12%, right? So if you compound your interest lots and lots of times, the interest you get each month is not going to be, it's not going to look like a lot. But by the time you finish doing all of them, simple interest. I'm going to do the last one. Now, folks, who wants to write out 1,000 times 1.01 12 times? Does anyone want to do that? Did anyone already write it down? I bet I'd have to really twist your arms to get you guys to write out 1.01 times 1.01. So what would you write instead of 1.01 times 1.01? 1.01. You write what, Vanessa? Yeah, to the power of 12, right? Because nobody actually wants to write that out. So you just use the definition of exponent and make it easy for yourself. You can say, oh, it's 1,000 times 1.01 to the 12. And then, would you actually type all those in your calculator? Or would you be like, times 1.01 times 1.01? No, you would just write 1,000 times 1.01 to the power of 12. And we should all end up with 1126.82. Now, I have a very important question. Will this number keep getting bigger and bigger and bigger forever? Like if I just keep on compounding things more frequently, can I just make this amount grow to infinity? Can I be like, hey bank, compound my interest every second, and then that amount would just get bigger, bigger, bigger? Where does it cap out? Let's just take a look real quick. When n was, let's see, that's 0, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the number of compoundings. Wait, 1, 2, 3, 4, 5, 6, and then 12. And then what were my dollar amounts? Roughly, I'm starting at 1,000. And then I go up to 1,120. Gosh, how can I do this so it looks good? This will be 1,100. And this will be 1,200. Does my scale look correct? Maybe a little further down on that one. There. Does that look like a good scale? Well, I'm starting at 1,000. The difference from 1,000 to 1,100, from 1,100 to 1,200, do those increments look the same? Roughly? Okay, so where do we begin then? The first dollar amount was 1,120? No, I'm sorry, just 1,000. Yeah, 1,120. So 1,100, and then I'll break this down. 2, 4, 6, 8, 10. There we go. 1,120. There's my first data point. After 2 compoundings, it was 1,123. So barely higher, right? And then 1,125, barely higher again. And then 1,126, barely higher again. And then 1,126, almost the same data point. So actually, what happened to our curve? Yeah, it's turning into a flat line, right? It's approaching a what? It's approaching an asymptote. It is, in fact, approaching an asymptote. There will come a point where it doesn't matter if you compound it more and more times. You're going to reach the asymptote of, okay, that's the most that you can get. And there's actually a word for that. When you compound anything, let's just say 1 billion times a year or 1 trillion times a year, they just call it compounded continuously. Compounded continuously, they're giving you the interest that you would have earned if you were at the asymptote. Continuous compounding. Technically, continuous compounding is n equals infinity. That you're compounding it infinitely many times throughout the year. I mean, I know that sounds silly, you can't do something infinitely many times, but that just means give me the interest rate that is equivalent to the asymptote. That's how much interest I want. All right. Well, folks, that was a conceptual look at what compounded interest looks like. And so the last thing I'd like to do is just show you that the formula matches, that the formula really does match. So for instance, I'm just going to come over here real quick. If I write down the compounded continuous formula for n equals 2, that would be 1,000 times 1 plus 0.12 divided by 2 to the power of 2 times 1, which is 2. And what is that? What's 0.12 divided by 2? That's the 0.06 that we mentioned. And how many times am I going to have 1.06? Twice, which is 1.06 times 1.06. So the formula matches up with the conceptual of what we were even doing. Likewise, what if we did n equals 4 times 1 to the power of, again, this is nt, we're just doing it for 1 year. So it's just n. So that's the 4th. So what would that look like? 1,000 times 1.03? 1.03 to the what? The 4th power. And how many times did we multiply 3 times itself? The 4 times. So this compounded interest formula really is giving us this conceptual idea of what we were doing with compounded interest, which is giving you interest more times per year, but less of it each time. And that's another definition you could give someone. What is compounded interest? You're getting interest more times per year, but at smaller amounts each time. Okay, well folks, that was my conceptual overview of compounded interest. That was it. So at this point, I want to just go back and we'll just try it out. We'll try some of these problems. But I hope that that filled in some ideas for you about how simple and compound interest works. So everybody, back to your notes packet. And with all of this information in hand, we can really get a good idea of what's happening in these problems. Go ahead and read the first one yourself. Does everyone have one of these?
Yeah.
Okay. All right, so read that for us. Oh, how about one of you read it for us? Genesis. All right, fantastic. That's a lot of information in there. Folks, first things first, let's just write down the formula. Because I do want you to memorize this. So amount in the bank at the end equals your principal times 1 plus r over n, all to the n t. And the first thing you might want to do, that would be very, very helpful, is just identify all that. Identify all that information. Before you go plugging things in, just jot down what each letter represents and find out how much it was. So what is our P equal to, Kimberly? Yeah, 4,300. That's our principal. That's how much we're actually going to invest. And then Amber, what's our R?
Is it the 4 years?
It's not the 4 years. R is rate, the interest rate.
Oh,
Yeah, 7%. And instead of writing down 7%, folks, what do we write?
0.07.
Yeah, 0.07. All interest rates we always calculate as decimals. We never actually do any computations with percents. You always convert it to a decimal first. Okay, so then what is our N equal to, Ingrid? Yeah. Well, yeah, 4. Well, wait, what do you mean? What did you say? 4 years or 4 times per year? Yes, 4 times per year. The word was quarterly. So, yeah, because it's quarterly, we know that N is equal to 4. This one was tricky because what's our T value, Liliette? How many years? Yeah, just 4 years. So, but those 4s mean different things. The T is how many years are you going to invest it? For 4 years. The N is how many times per year are you compounding your interest? That's 4 times per year. So they're both the number 4, but they mean wildly different things. Okay, folks, we have all that information. Now you can go ahead and plug it all in. All right, so we'd have the 4,300, and then 1 plus the interest rate of 0.07 all over 4, all raised to the power of 4 times 4. Who's got 0.07 divided by 4 for us? So,
I added the 1, sorry.
So, I'm sorry, what is it?
0175.
0.0175. Okay, so just multiplying, dividing 0.07 divided by 4, it's 0.0175, and the exponent 4 times 4 is 16. So what we have here is 4,300 times 1.0175 to the 16. So before you actually compute that, I just want to ask you, how many total number of times are they going to give you money? How many times are they putting a little interest in your account? More than 4. Total, over the whole 4 years. 16. That's what the exponent represents. That is the total number of times you get interest. That's how you interpret the exponent in this problem. And that probably just makes obvious sense, because if you're getting interest 4 times per year for 4 years, 4 times 4 is 16, so that's 16 times you're getting interest. But now you can just look at it and say, oh, I get interest 16 times. And how much interest do you get each of those 16 times? Yeah, 1.75%. So even though the interest rate in this problem is 7%, and that's true, it's 7% annually, you're actually getting 1.75% in interest every time they give you interest into your account. So if you wrote that out, folks, it would be painful, right? It would actually be 4,300 times 1.0175 times 1.0175 times 1.0175. And you would keep on doing that 16 times And that would be a nice little calendar of what's about to happen to your bank account over the next 4 years, right? So if it's 4 times a year, that's January, February, March. So that would be the end of March. And then April, May, June, that'd be the end of June. And then July, August, September, that'd be the end of September. And so on as you march through the year, that would be an indication of all the money that they're putting into your account. Okay, well, I just show that to you again so you get the conceptual idea. What's the actual value on your calculator? And folks, can I encourage you to try to do the base to the exponent first and hit enter, and then multiply times the 4,300. Because I see a lot of people do 4,300 times 1.075 to the 16th, and sometimes it accidentally raises the whole thing to the 16th. You know, 4,300 times 1.075, and then that gets multiplied to the 16th? No, that's wrong. You need to do the exponent part first, so do 1.0175 to the 16th, hit enter, and then multiply times 4,300. And what do you get? 5675. 6961. Okay, so what should we round that to, folks? $5,675 and 70 cents. And so that's the total amount of money you have at the end. Now we could ask more questions about this, like how much interest did you just earn? How would you find out? Subtract the 4,300, right? We can go ahead and do that right now. Just a little scratch work. Subtract the 4,300. That's 1,375.7. So we just earned $1,375 in interest alone, whereas this was your total. Right? So there we go. I could ask you any of those questions for the test. I could say, what's the total number of times you're going to get interest? And what's the total number of times you're going to get interest? 16. How much interest did you actually get each time? 1.75% each time. Whereas what was the annual percentage rate? 7%. So that's a lot of specifics to read into that. Okay, let's try it again. Number 20. I think you can all go ahead and try this one on your own. I would just like to, again, encourage you, write down the formula first. We're trying to memorize this by the end of today. 1 plus R over N, divided T. And go ahead and jot down P equals, R equals, N equals, T equals, and find all those values. So go ahead and give it a shot, folks. I would write down the formula first, identify your variables, and then plug it all in and type it into your calculator and see what you get. Cool. Okay, folks, so we review our answers. Let's see here. First of all, the principal, Sydney, was what? Yeah, 2,500. And then the interest rate, Vanessa?
Like 4.
Yeah, 0.04. And then the number of compounding is Eduardo? Because semi-annually in the year. And then the total number of time was Amber?
11.
Yeah, 11 years. Okay, great. So that's all of our information. And now we go ahead and plug it all in. So I bet you all got something like 2,500. 1 plus 0.04 divided by n, which was 2, all to the power of 2 times 11. And so first question, how many times are you actually going to get interest? Yeah, 22 times. You're actually going to get interest 22 times that they're going to sit there and deposit a little bit of money into your account. And then at what interest rate are you getting that interest rate? Every twice a year. Yeah, 2%. So you're actually earning 2% interest twice a year, which is the advertised 4% annual interest compounded semi-annually. Okay, well that's it. And then you just type that in your calculator. What was your final answer, Ingrid? This part? And then multiply times 2,500. You know, that's fine. Go ahead and just multiply times 2,500. 3864.94? Okay, folks, did you get that?
Yep.
386? Oh yeah, that's fine. If you rounded it to 94, 95. What was it, Ingrid? What was the third decimal? 0.94? Oh, 0.949. Okay. All right, well, there we go, folks. And how much actual interest did you earn? Did you subtract off the 2,500? It was 1,364.95 cents. Great. So that was the actual interest. Now, I have terrible news for you. I just looked up on Google what semi-annual and biannual and all that stuff meant. Apparently, semi-annual and biannual mean the same thing, twice a year. Biennial means every 2 years. So if you ever do anything every 2 years, that's biennial, which, you know, has an E instead of an A. Have you ever seen anything more crazy in your life? English. Okay, now, bi-monthly. What did that mean? Anyone want to take a guess what the Google told me? Twice a month or every 2 months? Both. Context should determine which you mean. So if you say to someone bi-monthly, like, hey, you're going to get paid bi-monthly. You want to clarify with them, now, which bi-monthly do you mean exactly? I'm going to visit you bi-monthly. Your in-laws are going to visit you bi-monthly. Now, which is that, every 2 months or twice a month? Right, you might want to know. So apparently it's just according to context, and that's it. All right. Well, very nice, folks. So let's see. The next question, find the amount of money. That looks pretty similar. Find the amount of money. That looks pretty similar. 10 months. 10 months. No, 10 minutes. Take 10 minutes and go ahead and work out number 21 and 22. And I'll just walk around and check your work. So don't mind me hovering. And if you have any questions, you can ask them. And by all means, if you want to work with your table buddy or check your answers, that's a good time to do it. By the way, folks, all of your work looks very neat and tidy and organized. I would hire any of you. Could you even imagine it? What if your next employer, during an interview, they said, be sure to bring your resume, your cover letter, and a piece of math work that you've done. And that would be their understanding of how neat and tired you are. So because you already have your one already. That's not true. So the fact that it's not up. 18 and 7. So how much additional money did you get? So then,
More important is it works. That's what we're back is the hotel. Might just And then have you been typing this part? Yeah, anything else? Yeah, that's just being multiplied, right? Okay, good. This is up to you. I understand that everyone's going to be in the afternoon. And so you notice that part. If you can make it other part, that's something. You got this whole thing, that's what I won't judge you because and you can always watch the class video later. We're going to go through the whole practice together and I'll probably start exercise. Good. Oh, and I like how you're in the computer. And then that's good. That's the end. It's a long. It's a long. You might want to jump to the end. So they have to know. That's it. You could either do this one, or keep in mind that this one is that one.
Yeah.
I know that. I don't know. No. Okay. Very nice. Very nice. I'm going to. Very good. This is nice. Oh, walk around. Any questions? Get all that under there? That's what I do. Now this was 1.05, right? I thought it was what?
Oh, yeah.
I didn't know it was just a high. That's every once in a while we push the button and it doesn't work out. I'll do that one more time. It's 12 times 7. There you go. Now you're gonna do it. Sure. What's this one? Oh, okay. So essentially you just took all that and threw it in the calculator.
Yeah.
So, and that's just fine. So keep in mind that the test I might say, how many total times do you get interest? What's the actual interest you get each time? Okay. And so showing that intermediary answer, then the answer is showing. Otherwise, that's really good. Obviously, you know what you're doing. How'd I go down? Super. Emma, did you finish it? Am I fixing something? Okay, I will. Looking good. All right. Question? No. Good. Anger? Yeah. You did. Yeah. The point is that it should be 0.005 and then the 132. Yeah, that's okay. Let's get this together. Very good. Come on. And Yeah, annually is just one. Yeah, one. Annually, that's it. That's one question. If annually is 1 year, because it's not biannual, it's just annually to be one. Annually. Because biannual is 2 times per year, whereas biannual is every 2 years. Then would it be the same to say annual or annual? I don't think anybody says annual. I think it's just like, done a very good job, right? But that's suggestions about it. Just what I hear. What's the number of times? It says how many months? So 100 right now, the number of times. But not that that's about. N is the number of times. So in this case, if you wrote down n equals 1 as if it happened once a day, how many times does that happen? It's happened 1 month. Well, so that number will be there we go. And then that will change that denominator as well. And then you got 21. There we go. So that will change the rest of that. Now, girls, the second one, context. That is just that's better. Oh, that's just so great. So you don't have to write that. That's just
I do appreciate it. It's like 6, like, the answer is me. So I just wrote anything.
Questions about where you are? All right. We'll back. All right, folks, walking around the room, your work all looks very good. Very nicely done. Let's review real quick. What time did our start class? I mean, what time did our class start? 12:30? Did I accidentally go past our break? Oh no, our break is at 1:40, which is literally in a minute. Oh, yep, it is 1 minute from now. Okay, well, we can just check our work real quick for these two problems. And I can ask you a question about it. So the top one, I'm going to do it down here if you guys don't mind. So I'm doing number 24. It's, wait, we didn't do 24, did we? I didn't change my screen, did I? No. We're doing 23? Oh, okay, 23. So number 23.
No, 21.
Oh, it is 21? Okay, sorry. Thank you, guys. Thank you. 21. We're actually doing number 21. So find the amount of money after 11 years, so I know to use 11. 12,400, that's my principal. And then deposit it at 6%, and it's compounded monthly. So what's our end value? Oh yeah, 12. Yeah. 12. Okay, great. And then you plug all of that in. Now, I know that you all plugged it in correctly, and you ended up with 1 plus 0.06 over 12, and then to the power of 11 times 12. And so here's my key question here. Before you even finish the problem, it's 1.02 to the 132, right? Okay, so how many times are you going to get interest? 132 times. You'll get interest 132 times over the life of that investment. There will be 132 times where they actually put a little bit of interest in your account. And how much interest are they putting in each time? 2%. You say, 2%, that doesn't sound like very much. But remember, that's 2% of your principal and your rate. I'm sorry, is that too wrong? Yeah. It was 0.005. I'm sorry. Okay, 0.005. So how much interest are you getting? What is 0.005 as a rate, as an interest? You have to move it twice? So that's actually 0.5%. Okay, sorry for that typo, folks. So 132 times over the course of that 11 years, you're going to receive 0.5% of whatever is in that account. But they keep doing that for you every single month over the whole time. So you're only ever actually earning 0.5% every month. But if you spread that over the year, it is exactly 6%? Are you earning exactly 6% after a year of that? Or is it just more than 6%? It's just more than 6%. Everyone on your calculator real quick, actually do 0.005 to the power of 12. right? Because you're doing 5% every month. So if you do 0.005 to the power of 12, what does it turn out to be?
0.441.
0.005?
Yeah.
Sorry, 1.05. I'm sorry. I need to calm myself and say the right thing the first time. 1.005 to the power of 12. 1.061. Aha. So how much actual interest are you getting effectively?
6.1.
You're actually getting 6.1%. So if you just had simple interest, it would have just been 6%. But because you were compounding it 12 times a year, you actually ended up with the net result of 6.1%. And do you know what this is called? That's called APY. Have you ever heard of that phrase, APY? It's on every credit card bill or advertisement you've ever gotten. When they say that you can earn, or the credit card is only 5% APY. APY stands for annual, anyone want to guess? Percentage yield, yeah. So the actual yield of our 6% account, the APY is actually 6.1%. Because that's what you're actually getting. Even though it's advertised at 6%, what you're actually getting, because it's compounded monthly, is you're actually getting a little bit more than 6%. So that would be called the APY, the annual percentage yield. All right. Well, folks, let's take our break. The time is 1:43, so we're going to be back at 1:52. Hey.
So, we see guy confused.
Oh, I'm so glad you came up. I'm just sitting up here and I can help you.
Okay.
Let's see.
Okay.
This is the page we just did.
Mhm.
Yep, and you have all that written down. So is your question about this one?
Wait, so about this,
Oh, yeah, okay.
like, are you asking something about that? Like, what exactly are we choosing?
Well, this was just me throwing out a little extra info at you.
Oh,
To help us all understand compound interest, simple interest, and APY. I'm just pointing out that when you compound your interest, you actually get more than the advertised rate, right? And that's the big difference between simple interest and compound interest. So if you're getting 6% simple interest, you're actually getting 6% interest. Compounded, how much interest are you actually getting? More than 6%, right? And that's what APY tells you. It actually tells you how much more you're actually getting because you're compounding the interest instead of just doing simple interest.
oh.
So I wasn't planning on asking that question on the test, but now that you mention it, maybe I will. But if I do, I will certainly give you more practice. So
Okay.
probably on Wednesday when you come in, I'll put a problem like that on the board
Okay.
to remind everyone, how do you get APY? Well, let's just show how you did it. What you did was you took the interest rate that you're actually getting from the compounding, and you do it 1 year's worth. Yeah, because it was every month. So we did 1 year's worth, which is why it's called annual percent yield, because it's for 1 year. How much interest are you effectively getting at the end of 1 year? So that's why we did it to the power of 12 instead of 132. 132 is because you're doing it 12 times a year for 11 years. So that's all 11 years worth. I just did 1 year's worth in order to get APY.
Oh, okay.
Does that answer your
Yeah,
question?
yeah.
Because you're probably wondering where the 12 came from.
Yeah.
Yeah, well, that's a really good question. I'm sorry, apparently I did not describe that very well. In fact, I did not. I did not describe that very well. So I will say that again when we come into class because maybe I'll do it again for the next one. Actually, no, I'm not going to do 22 because everyone just was working on those two, so you two can go and finish those up.
Did you have a question about that?
No.
Oh, okay, just not done. But I will have us calculate APY again for these problems.
Alright.
And I'll say it again better. Thanks for asking.
I'll make this.
Done.
So the test.
The test. It'll look almost identical. Really? Well, that's a problem. I don't need that. What, graphical or the equations? Oh, graphical? Oh my goodness. Well, thank you for bringing that to my attention. Yeah, what to do? Oh, that is not my intention. But thank you for saying that to
So
me.
everything
I'm going
that you
to.
give us as far as practice and stuff is what's gonna be.
Yeah,
And
the
we go
practice
over in
test is
class.
what's going to be. But so for Wednesday, I need to make sure that I eliminate any questions from my math lab.
Because I was trying to get a one-to-one.
Not just what we were
Chapter
practicing.
11.
Yeah, not what we were practicing with the F of and the F inverse, but you're saying show the graph.
Yeah, show me how you do, how you look at different functions and see one-to-one. And I'm like,
Yeah, we didn't.
so
What the heck?
I was just trying to figure out how to do it. I just went over the problems, so there was maybe 3 or 4.
Yeah.
But I'm like, I need to go do the test and figure this out for the test. So that's why I asked you if
Yeah,
there was anything like that.
that's very strange.
So-
Excuse me. I'm gonna grab my computer real quick. Thanks for bringing that to my attention.
Then you have to add them to the test.
Right. But I mean, that's a really good point. I don't know why. What you're saying rings a bell. This is 120, not 150. 150, I know that we do that. Let me just look. Okay, Don, I know what you're talking about now. I did not intend to put it in my math lab if we didn't do it in class. So I will.
That's why it confused me then. 'Cause I'm like, I need to go back to the text.
Yeah, that would be confusing. Yeah, I don't want to throw you guys any curveballs. I'm not expecting you to
That's what I
learn.
was saying. I'm just gonna mail the test.
Yeah.
Are you guys talking about the
My math lab?
chapter 11?
Yeah.
The one-to-one where you do coordinates and, yeah.
I
got confused. I saw
I was
this.
like,
Oh, shoot. I'm so sad to hear that. I'm going in there right now.
All right, folks, I think everybody's back. Let's start back up again. So, we were just talking about how compounded interest is better than simple interest. Better for who? Us? Is it always better for us? I mean, it's better for whoever is getting the interest, right? So it's better for you if it's your money in the bank earning interest, but when is it bad for you? When you use your credit card and you don't pay the balance off at the end of the month, then they're charging you compounded interest. All right, now that's the thing though. When you get a credit card bill, they have to advertise and tell you the annual effective or the annual percentage yield. So that's what a credit card is actually telling you. See, when they tell you that the APY is, let's say that they're going to charge you, what's an average amount that credit cards charge interest rate wise?
29%.
29%, maybe somewhere in the 20s. They charge a lot of interest, folks. So let's just say it's 25%. What they're actually telling you is the APY. They're telling you the effective yield. How much are they really charging you per year? Probably a little less than that. But then the interest is compounded, so it goes up to this higher value. So what they're actually charging you is, say, 23%, but it's compounded daily, right? And so compounded daily, that 23 shoots up to 25, right? And that's the APY. That's effectively how much interest you're getting charged by the fact that they've compounded it many times. The interesting thing is, a couple years ago, well, actually, it's probably more than a couple years ago, but if you go back into U.S. history, maybe in the 90s, I forget now exactly when, but there was a law passed stating that all credit card companies had to tell you the APY because that's only fair. I think it was actually called fairness and, not fairness in advertising, but that could have been part of the bill. Because, see, you know what credit card companies were doing? They would say, hey, get our credit card. We're only charging you 23%. And is that true? Are they charging 23%? Well, kinda. They're charging 23% compounded daily. And so that was kind of misleading. People would get credit cards and they're like, hey, it's only 23%. But then they'd go to pay their bills and they're paying it off and they're like, man, I'm paying a lot more than 23%. And the credit card companies are like, well, yeah, because we're charging you compounded daily. So finally, a law was passed that all credit card companies and lenders and mortgage lenders and all of them, they all have to give you the APY, because that way they're not misleading you by the base rate, right? This would be the base rate. This is the compounded rate. So you can all be grateful that this thing called the APY exists because it's your annual percentage yield. It's effectively what you're paying on that credit card, even though they're technically charging you less. How do you feel about that? That a couple decades ago, credit company cards were like, yeah, it's only 23%, see? You know, because they had to actually legislate and get a law passed so that credit card companies couldn't keep doing that. Okay, so all that said about APY, let's try that a couple more times to calculate APY. So this next question, now we really are on 23, right? Yeah, so Barry Newman, wow, what a specific name. Barry Newman, not just Barry, Barry Newman. account has a balance of 1887. So what's that?
That's the principal.
That's my principal. So my principal is 1887. And after 11 years, so T is 11, what will the amount of interest be at 4% compounded annually? All right. Now, at least a couple of you asked me, hey, if it's compounded annually, do I have to use the compound interest formula? Or can I just write the simple interest formula? Can I just write P 1 plus R to the T? So what do you think?
Either one will either one.
Either one works. It's totally true. Either one works. Now it's up to you. You know, I only want to have my brain memorize as little as possible. So I just memorize the compound interest formula and I'm done. But if you want to memorize both and you just remember that you have two different formulas you can use, then you can memorize both. But I just like to memorize the one with the N in it. So we go ahead and we calculate. So the after 11 years, what will the amount of interest be? So 1887, 1 plus 0.04 to the 11, which is really 187, 1.04 to the 11. Okay, so then you compute that. What did you get? And remember, folks, I really do recommend you do the exponential part first. Type in your calculator 1.04 to the 11th, and then hit times 1887. So what did you get? 1790? Wait, what?
1017. Oh, I'm sorry. I'm sorry. 2904.
2904
95.
or 95. All right, great. Okay, so if you notice in the back of the packet, that's not the answer. So what are they actually asking us for? What will the amount of interest be? Because keep in mind, this is principal plus interest. Right? That's everything all lumped together. That's his original money plus the interest. And so how do we get just the interest? Yeah, subtract the 1887, which is what? 1017.95. Oh, there we go. Deegan, was that the one you were telling us?
Yes.
Oh, okay.
Sorry.
No, no problem. Yeah, so that's just the amount of interest. Okay. So, challenge question. What's the APY in this problem? Effectively, what are they charging you of interest rate? Or what interest are you getting each year? 4%, right? The APY is actually 4% because they're just doing 4% compounded once. It's simple interest. So in this particular case, the APY is 4% because it's not compounding at all. It just is actually 4%. So you would, in this case, say the APY is 4% because it is, right? It's just when you compound the interest that you would have to do a special calculation to determine the APY. In this case, simple interest is the APY. And in fact, number 24 is the same way, right? That's just compounded annually. So can I leave that one for you folks? So Sumi Kato, do you think I'm pronouncing that correctly? Sumi Kato? Anyone? Okay, I think that works. The savings account has a balance of 748. After 7 years, what will the amount of interest be at 4%? 4.5%. Oh yeah, 17 compounded annually. Okay, that's the same problem. Same, I mean, same enough that I don't think we'll go over it together. So let's go ahead and take a look at 25. Considerably different. Folks, I did not see another problem to calculate APY with you. I want to go back and do another APY problem with you because I feel like I went over that too quickly, and I really would like to be able to ask you to calculate an APY for me on the test. So where was the most recent problem that compounded something? How about number 19? You want to look back at number 19? I'm going to give you the instructions for how to calculate APY. So, APY. Since it's the annual percentage yield, we want to know the amount of interest you're getting for just 1 year. Just 1 year, Matthew.
Is APY the same as EAY, effective annual yield?
I don't know. Look that up. I don't want to answer wrongly. All right, so we were doing 7% compounded quarterly. So I know the inside is 1 plus 0.07 over 4 times T, right? So you'll notice a couple things. First of all, I didn't put the principal in front. because all I want to do is calculate the rate, just the interest rate. So to calculate APY, you remove the P because you're not interested in how much money you're investing. You're interested in this part, which is how much, what the interest rate is going to be. And then what should I put in for T? Since we're trying to find the annual percentage yield for 1 year, you just put in a 1. So that would be your formula for APY. The formula, okay, well, that I already plugged everything in. The formula for APY is just 1 plus R over N to the N. You'll notice that this formula looks a lot like the compounded interest formula, except what? What's different about it? 2 things. Yeah, I took out the P and I took out the T. Now, I took out both of those for different reasons. I took out the P because I'm not actually interested in the amount of actual interest I got on that amount of money. I'm just interested in the interest rate, which is this component. And did I take out the T? No, I just set T equal to 1. So that's our APY formula. So let's go ahead and calculate. That would be 1 point, I forget, 175 to the power of 4. Is that it? Yeah. Yeah, go ahead and compute that on your calculator. So 1.017. And it turned out to be 1.071.59, etc. So how do we look at that answer and get the answer of the APY? Yeah, we're only interested in this part, right? Because the one is just there because we're including the principal and the interest, so you can effectively ignore the 1. So we're really looking at 0.07185. And what do you do with the decimal? Move it twice to the right. So what is our APY? 7.185%. Which you will notice is higher or lower than the advertised rate. Slightly higher, right? Because you're compounding the interest, you're getting a little more interest. So even though they're advertising a 7% interest rate compounded quarterly, the APY is the 7.185%. That's what you're getting. So I don't mean to throw this in there to give you one more thing to memorize. Hopefully this is a matter of memorizing the concept, that you're taking the same formula that we're already talking about, but you're plugging a 1 in for T because you're only interested in 1 year because you're looking for the annual percentage yield, and you just get rid of the P because you're not interested in that particular amount you invested. You're just interested in the interest rate. Okay. Jasmine and Emily, you asked me about that over the break. Does that sound better? Okay. All right. Well, folks, let's go ahead and keep on going to this last section, which is about radioactive decay. Now, why do I mention radioactive decay? What is all Chapter 11 about again? Chapter 11 is all about? Chapter 11 is all about? Graphs. Graphs? Well, a little bit. Yeah, we're looking at graphs. What kind of graph is this again? This is, yeah, exponential growth. And then if I change this ever so slightly, it becomes, no, that changed it too much. And then this is exponential decay. So we want to look at both situations. We were looking at exponential growth of interest in a bank, and now we're looking at exponential decay of a radioactive substance. So let's look at this radioactive substance. It says, a sample of 200 grams of some radioactive substance decays according to this function. So I'm going to go ahead and type that function in. It's 200 times e to the negative 0.033 t, or x. There we go. Now my graph, what happened on my graph? Nothing, right? Do you see the graph? Because I haven't zoomed out enough to, whoa, there it is. Okay, now everyone sees the graph. Everyone, take a look at the graph, and what do you notice about the y-intercept? Yeah, the y-intercept is at 200. Now, why should that be? The y-intercept is 200. It's what, David?
Y is equal to 200.
The y-intercept is equal to 200. What about the problem tells us that? that at time equals 0, keep in mind, the y-intercept is when time equals 0. So if you look down here on the x-axis, that's time. And what are we measuring time in? To the nearest year? Let me change my x-axis again. We're just doing time in years. So I'm going to change this to 10, and I'm going to do that. Whoops. 50 years. There we go. So there's my graph again. It now just looks like a much more gradual curve. You can't see the asymptote yet. But the idea is that the x-axis is years. So after 0 years, how much do you have? 200 grams, right? Because that's what you started with. It says a sample of 200 grams of radioactive substance decays according to that function where t is time in years. So if we all look at this function again, it's telling us a story about this radioactive substance. It says that in the beginning, at time 0, you have 200 grams worth of this substance. And then as the years tick by, like for instance, how much of the substance do you have left after 10 years? Approximately. Somewhere between 100 and 200? A little less than halfway. The coordinate here says 144. So after 10 years, I only have 144 grams of this substance left. How many grams do I have left? Yeah, just over 100, right? It's just above the line. And then after 30 years, how much substance do I have left? Yeah, between 70 or 80, definitely less than 100. And then after 40 years, yeah, right around 50, halfway through. So we can see here that this graph is simply telling the story of this radioactive substance as time goes by. And it's decaying exponentially. Where, what's the base of this expression? Maybe you've never seen this before. What's the base? The letter E. Now, I'm betting that you all know the number pi. What's the number pi? Yeah, 3.14, right? Et cetera, et cetera, et cetera. Well, E is just another very useful and famous number in mathematics. I honestly don't think we'll spend much time using E in this particular class, but next semester in 150, if you take 150, just get the number here real quick. E is a mathematical constant. And yeah, there we go, 2.71828. Everyone, let's write that down together. E equals 2.71828. So that's the value that's in this problem that we're looking at right now. Okay? Now you might say, why are we looking at that number? Why did E get to be so special? What's the deal with E, 2.71828? I mean, it's close to pi. Pi is 3 something, E is 2 something. Why should that show up in an exponential problem? Well, I definitely want to show you. But how does everyone feel about the graph so far? So if we just wanted to answer this question, we could just look at the graph. What was the answer again? How much of it is left? About 75. You can write that down if you want, to write approximately 75. Well, let's find the actual answer. So let's find the actual answer. How do we find the actual answer? The formula is the amount of the radioactive substance as a function of time is 200 e to the negative 0.033 t. So if we want to find after how many years? 30. So you plug in 30. This is function notation. The input is 30. So you literally input the 30 into your function. Now, folks, you're all going to take your calculator and plug this in. And you're going to plug it in very carefully. I, once again, recommend you do the exponential part first, and then multiply times 200. Do the exponential part first, and then multiply by 200. But when you do the exponential part, you might even want to do the decimal part first. So it's 200 e to the, what's just negative 0.033 times 30? Yeah, negative 0.099. So maybe do that part first. I'm just counseling.
It's actually 0.9.
Oh, 0.99. Thank you. Oh, yeah, because it's times 30. 0.99. There we go. Yeah. I would break down your computations as simply as possible. I only say this because I so frequently see calculator errors. Now, what I'd love to do is sit down with each of you one-on-one and make sure you know how to use your calculator. But you all have a different calculator, and you would have to swing by my office. And by all means, I invite you. Swing by my office, and I'll show you to make sure you're using your calculator correctly. But your best bet is to do simple computations first, and then always do the exponential. So did everyone already do 2.71828 to the power of negative 0.99? Calculate that, and then multiply it times 200. And let's check to see what everybody gets. Remember, we already guessed what the answer was. We guessed by looking at the graph. The graph was, yes, was approximately 74 grams. So let's see if your calculator gives you the same answer. Oh, okay. Folks, one more piece of advice. When you calculate E, maybe you don't even know where E is. See, this is what's tricky. You got to find E on your calculator. Folks, I'm just going to point out on Deegan's here. You should all have a button somewhere in your calculator that says, LN. There's an LN button, and then if you hit second, right above the LN is a little e to the x. So you'd have to, so for you, Deegan, you'd have to go second LN, and then that gives you the e to the, and it should give you a parenthesis. If it doesn't give you a parenthesis, type a parenthesis, and then you put in the negative 0.99, and that's your e to the. And just that part alone, folks, you should get 0.371. So everyone attempt on your own calculator just to type in e to the negative 0.99, that should be 0.371. And as I walk around, please let me know if you get that. Is that what it was? Yeah, 0.371. Go ahead and attempt it, folks. See if you can get e to the negative 0.99. So yours, there's your ln, and there's your e to that. And then shift, e to that. And then right there, I'm going to hit parenthesis and do negative. That's what I got too. So now you try that. Okay, great. So, there's your ln. Try. Yes. How about you? You can do it on the phone. Back to the okay, here, let's just do the even. So, actually, so what is that? So then how do we do that? Now, let's try that again. Oh, yes, you got the first. Did it work? Oh, good. Oh, you can just type something. Just calculate it. Did it work? Did it work? You did it again?
Yeah.
Yeah, okay, good. And then that is the part that gets multiplied times 200. So this isn't the final answer. That's just e to the negative 0.99. Now multiply times 200. Yeah, in fact, wrap the whole e to the in parentheses there. So that's what we just calculated. Now times 200. Did it work? Yeah. Did it work? Yeah. Okay, good. Oh, well, now you have a very good point about sig figs. I wasn't even thinking about sig figs. I was just plugging in all the years. Sig figs. I'm not going to hold people accountable with sig figs. Because you know chemistry and sig figs, but maybe not everybody. So I would just do all the values. Yeah, like for instance, if you just type it straight in, I would like trust that. You have a very valid point about that sig figs. If you're in an actual chemistry lab, you have to do that. Okay. Did it work, Martha?
Yeah.
Okay. Done? Did it work?
Yeah, so we do have a round now, so you can just do.
Yeah, 0.371 is fine. I mean, ideally, we'd be typing in the whole thing
Right.
all at once,
Yeah.
and then it would just tell you.
Right.
So maybe play around to see how to plug it in all at
What
once.
the difference is.
Well, let's see. Here's your E button. Okay, good. And so there's your LN, and right there's E to the box. So we hit shift, E to the box, and then parenthesis, negative. So then you would take that and multiply it times 200. Okay, so there's that. Okay, let's see. You have an LN button right there, right above it. It's E to the X.
So you're gonna get second e to the x. Oh, now your question is e backwards. You have to type in the negative 0.99 first, and then when you hit second e to that, that does the computation. But that didn't. So let's do what? Oh, okay, see, okay, thank you. Everything's right. So now when you hit second, there it is. So you get to type everything in backwards. See, our calculator's weird. Doesn't it work? Yeah, and then you multiply that by 2. Okay, that again. Oh, yeah, you got it. And you. Oh, exactly. Sarah, that's I tried to.
Oh, thanks.
But this is the this is the cross out.
All right, folks. Thank you very much. Boy, I'm glad I walked around and got to see everyone's calculator because you will have a problem like this on the test. Now, folks, during the test, let's say you forget how to type it in your calculator. Can you just come up and ask me? Of course. I want to help you use your calculator, right? But now you've seen it once. So what was the final answer? 74.35. Okay. So that was, and the answer is grams. To the next question. This time, a sample of 650 grams of radioactive substance decays according to the function that, which, you know, this problem is almost exactly like the last problem. Other than the fact that the numbers are different, it's the same problem. So how much of the substance will remain after 10 years? Yeah, Jesus. The previous one, yeah. Oh, it says round. Thank you, Jesus. It would just be, yeah, because it says round to the nearest whole gram. So everyone agree, 74 on the dot? Okay.
Yeah.
Matthew, that kind of responds to your question about sig figs, because they restricted us to 2 after all. I wonder if they did that on purpose. I don't know. All right. So this question, again, function notation, we're going to say A input 10. And so you do 650 d to the negative 0.115 times 10. Well, great. Everybody can practice this on your calculator, your new skill of locating the E button and raising e to the power of negative 1.15. All right. Now, it says how much will remain round to the nearest 100th year. That is a typo. It shouldn't say year. Because after all, what is the question asking? How much of the substance will remain? That's grams. Plus, we don't need to round how many years. How many years? 10. They don't. So that's just a typo. I'm very sorry. That's a typo. And so what was the final answer? 206? 206 point something and then you rounded?
Oh, it's 205.
205 point something and then you rounded. Okay, great. All right, folks. Now, that's the end of our notes packet. But don't go anywhere. Don't pack up. I still have plenty to do with you. How much time do we have left? 2:20. Lessons when? 2:50. Okay, good. All right. So, had a couple good questions during the break, and I'm glad I did. Folks, a couple of you came up and asked me questions during the break. By all means, please do that. It's a break for you. It's not a break for me. I'm happy to help any of you during the break, right? I don't need a break. I'm just sitting there waiting for anyone to come up and ask me a question. So feel free to ask me questions. Someone asked me a really good question, which is that my math lab had questions that we had not done. Did any of you notice that?
Yes.
For chapter 11? Okay, so I apologize for that. That is a mistake. I never want to give you work to do on my math lab that we did not do here in class. I'm not trying to throw you to the wolves like, haha, go try these problems. No, I don't want to do that to you. All the same, I did accidentally assign you some problems in my math lab that we didn't cover. So already now over the break, I went in and I removed those questions, right? I removed them because I don't want to make you do something that we didn't do in class, and because I'm not going to put it on the test, right? It won't be on the test. So some of you might have already done those my math lab problems. And for those of you, I think you'll just notice that the problem's been deleted in one way or the other. And otherwise, I'm sorry that you did the extra work, but hey, that extra practice you got, Right? You built some new skills. Okay, but otherwise, everybody, I think that you should be good to go now, that you won't see that on there. Okay, so what we're going to do next class is go through the test review, and I'll tell you now what we're going to do. On a test review day, which again, we won't always be able to do test reviews. In fact, they're not in the syllabus. I don't have quote unquote review days in the syllabus. But if we ever finish a unit early, like we're doing on chapter 11, we'll have a little time that we can spend some time in class doing the practice test. So what we'll do next time, read along with me, your test review. Oh, I've got writing all over the board. What we'll do is a nice interactive student participation review of the material. And here's how it goes. You'll take turns coming up to the board at about 2 at a time to complete a problem. So what I'll do at the start of next class is I'm going to write up the numbers 1 through 20. And before class starts, everybody can come up and sign up for one problem. So you just come up and put your name somewhere. You're going to do number 5. So on Wednesday, kind of early, you'll get the first come, first serve as to which question you're going to do. All right, the later you get to class, you're just going to sign up for whatever problems are left. And I'll make sure that I have at least 28 problems to do, because I realized the practice test only had what? Were there 20? Oh, 24 questions? Okay, good. So I'll just make up 4 more questions so that everybody gets to do 1 question. So you'll come up and sign up for a question, and then what will happen is I'll have the first 2 people come up on the board to write up their solutions. But we're not going to be watching them or making them feel nervous or anything. We'll just be ignoring them, and I'm going to walk around the room and help you and answer individual questions about the practice test, and you can be working together to compare your answers with your buddy. Okay? Meanwhile, once they're done, those 2 people are done and they go sit down, I'll call for everyone's attention. I'll say, okay, everybody look up here, and I'm going to review the 2 solutions that the 2 students just put on the board. And we'll just keep going like that. After I'm done reviewing, I'll ask the next 2 people to come up. They'll write up their solutions while I'm walking around the room helping everybody. And then once they're done, I'll come back up, I'll review those 2 solutions, and we'll just keep doing that the whole hour. I just wrote. Meanwhile, I'll be walking around the room answering questions one-on-one. After each pair of students finishes writing up the solutions, I'll come up to the front to review the solutions with you as a group and answer any questions. And otherwise, while I'm walking around the room and 2 students are at the board, the rest of you are using that time to review your practice test with your neighbors. So this review that we're doing, we are going to work all the way through the practice test, and that way you get to see every single solution, which should be very helpful. You've seen every solution. But you'll also probably have a little bit of time to finish your notes packet. So remember, you have 2 notes packets. You have your Chapter 5 notes packet, and you have your Chapter 11 note packet. And both of those need to be complete by the day of the test, which is next Monday. Okay, any questions about all that? Okay, I really hope that this won't make anybody feel too nervous, because like I said, even though you are coming up to the front of the room to present a solution, nobody's going to be watching you, right? It's not like you're actually presenting for the class, you're just writing it up. All right, any questions? Okay, so then I think what we'll do right now then is we'll go ahead and use this time for me to walk around and help anyone one-on-one, and for you to finish your Chapter 5 and 11 packet. This is a rare treat to actually have class time to finish things so you don't have homework, and because that way I'm a resource student. So folks, what I'm going to do is I'll just start walking around the room. Hey guys, 1 second. Almost. I'm going to start walking around the room, and when I get to you, have a question for me. I know that you might say, I don't have a question for you. But really, try to have a question for me. This is one-on-one time. This is a chance for me to work with you. So see if you can go back into your notes packets and find a question you'd like to go over. And then if I find something really good, I'll come up and share it with everybody. All right? Okay. Well, folks, this is our time. Answer any questions about the practice test or your notes packets. And I'll just start walking around the room this way, because I already see 2 hands up. Okay. Yes.
This is just the general instruction at the beginning of the test. That's just, I mean, good question. Well, to convert a percent to decimal, what happens? We start 4%. What? Well, there's a more specific thing that we're talking about. When you write 4%, where's the decimal right now? Like this. Well, you can write a percent decimal. So if it's 4.5%, yeah, you can do it twice. And so that's 1.5. Yeah, very good question. Oh, so it should be, if you do 1.04, and then you raise that to power 6. Oh, there it is. So power 6. There it is. That makes some sense. Oh, this one didn't work because this is compounded in. That already is. Yeah, that already is. I'm so sorry. Wow. Oh, and that's because that's not the end value. The end value is 1. Because you put it 1. Yeah, you put it in 6. So if you make that a 1, 1.04 to the power of 1 is just 1.0. Which is interesting. Now, I noticed that your calculator is automatically converting fractions. Okay. Yeah. Okay. So it did work. All right. So back this way. Okay. So you want to make them the same place. So what's the place? So we want to do it. So first one, minus 7.7. Go ahead and start second. Okay, so so is this Oh, yeah. Now you solve it. Right. It's just so happens that x equals 93. That's what I do. Well, x is equal to the whole time we were wondering, we are what? And that's what we said that. But lower. I can come up. Question?
Just, how would you break these answers?
Honestly, you don't really need to use these answers. I just want to see a more.
Okay.
But that's a really good question. I do want to see the good stuff. Yep. So that would be a negative or negative. Oh yeah, come back. When you say that. There you go. Okay, no question. Well, we're asking what really is the interest. So this is the component. I don't know. Whenever you calculate A is total amount. So like total. So how much of that was principal? Yeah, so you wouldn't add these two. Yeah. Let's see.
Or whatever you want.
Oh, and you know why? Because that's the years. I did change the problem. Yeah, I changed the problem. That's why.
And with that, I'm like,
Yeah. Thanks for mentioning that. This is the practice factor.
this is the chapter 11.
Yeah. Check it out.
Folks, real quick, just to share something Crystal pointed out to me. Remember how the very last problem had a typo? It said round to the nearest year, but it wasn't asking for years, it was asking for grams. That's because I changed this problem from a different problem. It was a problem asking about years, but I changed it to ask for grams. So if you look in the answer key in the back, it gives you the wrong answer. The answer key in the back says 6-something years, but that's from the original problem. I typed over this problem and made it something different. So just so you know, the answer key is wrong and what we said was right. So what did we say the total number of grams was? What was it? 206. That's correct. So just so you know, the answer key in the back is wrong, and the answer should be what we said in class. Thank you. Okay, Jasmine. That's nothing. And since we're talking about it, can I show you real quick? Because that's very subtle up there. I want to show you. So, when you do exponents in the of 0, first of all, the general rule is that anything to the power of 0 is 1. So, like, what's 1 times 0? Yeah. Now, this is very different. This says negative 13. It is negative. Yeah, exactly correct. And let's just see why. Had it been negative 13, that would have been because it's something without 0. But this negative 13, technically, anytime I say this is negative x, what's the number? And that's technically negative 1. And so we're doing the same thing here. That's technically.
Yeah, I know.
So, 1. See, the answer you told me is correct. Now this was negative. Okay. Yeah, keep looking for any questions that you have to go. So are you saturated? Okay. So in that particular problem, the same thing one has to do well. So because what's the number of systems? What's the yeah, they're both those. And so in that case, so this is how many systems. Yeah. If there was a decimal point after the 0, it wouldn't have to be 6. I'm a little less than that. 2? So there's 2 numbers. You have to have 1 there as well. And then 30, that would also be 1 because there's no decimal point. 30 is 2. But then this one is a decimal point. So that would be 3. And since we're taking that as a multiplier, it's multiplying. So then since the answer was 1, it's like 4. Should that mean that we should have multiplied 6? That would be 8. Because you can only 6, 7, 4, 7. It's been a long time since I've been. That's the beauty of mathematics. In math, you don't have Except when we're doing the okay, good, I think that's- Oh, you breathe in, like, oh my gosh, how do you not? Okay. You do, because of the two seasons. But I wonder how many fix that back.
So this is just has one.
I agree with the answer is that of course. And the direct ramp. All right, well, maybe I'll look up the same thing. And come back one day. Favorite question? You're gonna turn in on Monday to chapter 5, chapter 11. This is just your practice test. And this was an extra practice test that I just gave out today. You don't have to wait. This is the extra. Yeah. So on Monday, you'll turn in chapter 5, chapter 10, chapter 11, and the practice test. Now we go on. Yes. Done. Get a pencil. Oh, I'll be right there, folks. Yep. Okay, great. This is a subtle one. It is subtle. We're saying 2/3 to the what would equal 9/4. If you wanted to, you could even try to work that way. Start with the 2/3. What would I have to do to 2/3 to get the numbers 9 and 4?
Well, square 3.
Yeah, I'd have to square them, right? So 2/3 to the 2. 2 looks like a potential answer, except 2/3 squared would be 4/9. And that's not what I want. I want 9/4. So what would I have to change about this exponent? To do the reciprocal of 4/9. Negative. Right, well, we already found the answer. The answer is -2, which is it.
Right.
So that's just another way of thinking about the problem. What you want to think to yourself instead is to start with the 9/4 and say, how do I manipulate 9/4 to get it to turn into 2/3? Well, 9/4, just looking at the 9 and the 4, it should ring a bell that 9 is really 3 squared and the 4 is really 2 squared. And see, that's just pure number sense. I have no other guidance for you other than to say 9 should remind you that it's 3 squared. Kind of like when you look at 27. What's 27?
Well, that's the number I did that one. I thought it was, because it had to be negative.
Yep, it has to be negative, and it's 3 cubed. So in general, like, you should know your powers of 3 so that you just recognize 3, 9, 27, 81. Those should all be numbers you
I know the
recognize.
earlier one.
Yeah. Yeah, the higher powers of 2,
Fire
those are
is
tricky. So at this point, just looking at the 9/4, I know I want to get a 2/3 out of it. So far, I have a 3/2 out of it. 3/2 is close, but it's not exactly what I need. What I really need is 2/3. So that's when I say, okay, I'll just flip it and make the exponent negative. And that's a legit thing. You can flip anything anytime you like if you change the exponent to negative. Yep. So I don't know. Did I answer your question?
I think so, and I think I understand that. I think I just need to
Practice it. Well, here's one more for you. Let's say that I had 2/5 of what equals 125 eighths. Okay, digging in England. I didn't raise it. So, yeah, 4.5%. So, great question, and I should bring that up to everybody's attention. So, 4.5%. Let's say that it was just 4%. How do you convert 4% into a decimal? Well, where is the decimal right now? Yeah, it's right there at the 4, right? And then how far do you move it? Twice, 2 swoops to the left. So, same thing. If you have 4.5%, where's the decimal? It's right there. And so you have to move it 1, 2 swoops to the left. And anytime you make a swoop, there has to be a number in it. So this swoop has a 4 in it. This swoop is empty after 0. So I move my decimal and it's 0.0. Now, just for fun, I'm pretty sure there is a percent button. Oh, there it is. It's purple and it's above the parentheses. So just for funsies here, let's say I type in 4 and then I hit percent. I hit enter, turns it into 0.4. So let's say that I hit 4.5%. Oops. 4.5%. What should happen? It turns it into. Yeah, so you can always do that as well. Good question. Yeah. Okay. So you already have, go ahead, do the decimal part. Okay, you already did. So now do e to that. I'm going to see it. Where's your e to that? Oh yeah, there it is. So go ahead and hit second ln. There's your e to that. And then try to make it 1.15. Go to parentheses. Now that's just the e to the function. So hit enter. That's just it. Well, I don't know if you guys know. Oh, yeah, it needs to be negative 120. You guys said it. They're the buttons are right next to each other. Okay, so that's just that function. Now you have to multiply by 6. Did that answer your question?
Yeah.
Good question. And did it work? Yeah, I would always do the exponential part first and then multiply by the base. That's just my question. Yes. Ah, okay. So there's a couple different ways that you can think about this. Here it is. Oh, I did. So you can always fall back on this. It's just the definition. Like up on the top, I got 4 6s. I got 8 X's. Then you can just do the problem this way. No reason why not. 7 6s. I love 4 X's. There, so that's the definition. Then I go through and I cross out everything that I have to say on. And by how I have the answer that's It's a very intuitive approach. Just use the definition. The other is to do the closure test. It said beta x over beta y is equal to beta y. Subtract one. So yeah, exactly. So that would be 6 to the negative 3, and then x to the 4. I must have done something. I didn't list out the problem, but I should have been told. Oh, 8. Oh, I didn't write that as X's. You probably noticed that I got that wrong. Okay, so there we go. So now this, what do I do with the 6 to the negative 3? Since it's negative, it goes to the reciprocal and goes down. So there you go. That's 2 different ways to get the same answer. You just choose one or the other. Okay. Thank you for that. Question? All right. Okay. Okay. Oh, you finished it? And Sarah?
So, okay, this is on the practice of criteria, but I have more.
Oh, yeah.
So, since this just left as 1, this is 0, so that means this negative, so bottom, and is that cancel out?
Anybody just takes it out. So,
Really?
all you have here is definitely 7 is 0. And that's definitely.
Yeah.
That's definitely 7. That's definitely.
Right.
Okay, this is 6 total. It's actually negative.
Oh, just that one, okay,
So now, I was taking.
okay, that makes sense.
What you did here is you
Put it all
said
over.
6. Yeah, you did. You said that.
Okay, that makes sense. And then the other one I had. Yeah, okay. So on this, that's what came in because one. So that means hundreds, and then 1.2 is
1.20. Yeah. It didn't come out exactly.
41.0012 something, so,
Yeah, you would still just report it to me.
okay.
That's it. Continuously, obviously, that's a problem that I do. Oh, no, actually, we could be going, but I didn't do it for everybody. So I'm just gonna do it.
Oh, you're not gonna explain
Let me take it off.
I'm like, okay.
I mentioned it up there because what is compounded continuously? And it links an infinite. Yeah, but I didn't do it wrong. So I'll take that. What is that number? 19.
Cool.
Oh no, I'm so sorry. You can always email me, folks. If you get to a weird problem, email me immediately. Just hit email my instructor and send it.
I'm like, help me solve.
Oh, okay, no, you can do that. That's right. And here's why. Because this is actually those are so like
246. So you just have and now remember the rule. It's A to the that is not
Why don't we go on to practice?
that's how you do it. There you go.
Yeah, that one, yes.
Okay, folks, we just have a couple minutes left. Let me call back your attention real quick. Your quiz. Let me go ahead and pass that back. Now, just as a friendly reminder, okay, everybody, listen up real quick so you're about the quiz. The quiz I graded out of 20 points, okay, and that allowed me some flexibility in terms of assigning partial credit. Like if I saw that you had part of the idea but not all of the idea, I gave you partial credit. But you'll notice when I typed it into the gradebook, quiz is only worth 10 points. So you might have gotten a score like 7.25. That's incredibly specific, but that's because I did it out of 20 points, but I typed it in the gradebook out of 10 points. So just so you understand, when you see a score out of 20, but online it's out of 10, it's because I did it out of 20 so I could do more partial credit. Okay, second, please go through and look at all my comments, okay? Because I took quite a bit of time to show you the proper steps to do these problems. So please don't just look at your grade at the top and then throw it away. Go down and intensely analyze every problem and see what you did. And you want to analyze this quiz so well that if I gave it to you again, what would you get?
100.
You get 100, right? Okay, so Ingrid. Now, one other thing about the quiz or a test. By all means, if you think that I didn't grade you correctly, I sure hope you come tell me that. Okay? Maybe you know something I don't know, and maybe I did not grade it correctly. I can make a mistake. So please, if you think that for whatever reason my grading was unfair or incorrect, please come tell me. I know. Okay. And Jasmine, let's see. Okay, another thing to keep in mind, sorry I keep on having announcements. This quiz was out of 10 points. Keep in mind, if you sent me an email saying, hi, my name is, this is what's easy about math, this is what's hard about math, and here's a joke, how many bonus points did you get? 10. So that extra credit opportunity gives you a lot of padding for this quiz and all future quizzes. So I would encourage you to really take this as a learning opportunity. To really make sure that you've got your concepts right and that you're showing all of your work. Some of you folks, I took off points just because you didn't show any work. Jacqueline. Is Jacqueline here? Oh, there you go. Oh, yeah. Oh, you Jacqueline. Jacqueline. Okay, Jesse. So remember, I'm a really harsh, terrible, mean man, and I take off points if you just don't show all of your work. Okay. Yes, and I haven't put the extra credit bonus points in the gradebook yet, but I will.
Where?
Chris. And all right, folks. It's 2:51. I can't keep you here any longer. If you have any questions, please come see me. I'm happy to help. Dig in. Question. For this one, how do I show my work? Well, what I did, well, see, part of the main question is so many people gave the answer of 1 without showing work, and then a lot of people showed the answer of -1 without showing work. And it's tough for me to know whether or not someone knew that or if it was just a lucky guess. Now, I'm not saying for you it was a lucky guess, but in terms of work, my message at the beginning of the semester is that I want you to show enough work that, and someone just walking in off the street will be able to look at your work and know how you got your answer. So if you just write -1, it's not really clear how you got your answer. In this case, -10 to the 0. That's really a -1 out in front of a 10 to the 0. And now you know that 10 to the 0 is 1, so that's -1 times 1, which is really -1. Okay, some sort of indication. And the main thing you always want to ask yourself is, would that be enough for someone else to know how I did what I did? Okay, just wondering. Yeah, thank you, Deegan. It's a good question.
Would you also write, and we didn't show work and mark off
A little.
work? Okay.
Yeah, a little. I won't take